streams. And today we are going to build a linear regression model from scratch. So the first thing that we have to do is to learn about the mathematical intuition. Then we can build the algorithm on top of it. So let me give you a brief introduction about linear regression. Linear regression is actually a linear line or a straight line to find a point where the sum square residual is minimal, where the n error is minimal. This, with the help of the algorithm, we can find the independent variable, so the dependent variable from the independent variable. Okay, so let's start with it. So I have important codes, libraries, and data set, and I split it into training and test data, some basic stuff. So let's go and build the integration. Okay, the first thing that I'm going to do is to go to class. So in integration, we need to take account of four things. Mainly three things. It's the learning rate, bias, and weight, and binding, and iteration. So let's create some values. So what I'm going to do is initializing class, giving some values that are generic, that is all value. I don't know. You can choose a perfect default value of non-equal based on cross validation by the principal. I'm just giving this random number. And the number of iterations, this is something like unit rate. It's a triangle that you have to do cross validation to finding the best number of iterations. And the next thing is we need to take account of weight and bias. So if you take this equation, what we're actually trying to do is um, finding cost function, and we run the gradient descent to until we find a weight and a bias where the cost function is minimal. So the first thing that we need to do is not to fit the model. We have to first create an empty space through nb dot zeros, and I will do basement to do it. Okay, let's just finish what we started. So we declared the variables that we want. And now we need to fit them. Fitting them, we need to understand a few things. First is we really don't know what is the shape of our data. So we have to select two variables, such as example and features. Features how many features are there in the so let's do. So there are samples and features. and that's going to be the shape of x. The derivative is basically we are giving a default value to weight, and bias. The bias will always start with 0 because it's on the y-axis. So the next thing that we need to do is to run for the number of iterations. Now is the crucial part where we need to predict the one. It's a wrong prediction, but what we are doing is we are trying to make the prediction better and better over each iteration by using radius. So just give a run, just give a run about predict. Now comes the crucial part where we need to find the code function. Actually, we don't need to find the code function code because we have to. Let's say there is an equation. Yeah, you can see this GWP. It's actually this is derivative of GWP. So we are finding the derivative here. So you may ask a question in coding why there is no x here, because this is the derivative of bias. It does not have x because it starts with 0. Since it's on y, or it's a y intercept, it sits on x of 0. Okay, so let's implement this equation. Actually, from this equation, pretty much memorize it. So, if you look at the equation and do this algorithm, it's not a big deal. Don't think I'm a genius. Just recent issue. So the equations 1 by n summation of k okay, this makes sense. Go through that again. Yeah, it's correct. Yep. So the next thing we need to do is to run this gradient descent algorithm. It's basically updating the weight and bias over and over again till we get the minimum cost function, about the minimum cost value. So what we do is we run this equation. Okay. Self. So the next method is basically if it has one, we find the weight and bias, where the some most function is minimal. So next thing is predict. So we have okay. Now we just so we have weight and bias. And we have x. So we can do mx plus b. Basically, it's mx. M1x if it's a multi-variable like or multi-variable. Yes, it's a multi-linear regression. We can use like m1x1 plus m2x2 plus b. Okay, let's get to it. Okay, and to predict x self weight plus bias. So basically, we did our algorithm. Let's test. Enrich. So let's test it. Linear, linear regression, linear dot. Okay, yeah. The one thing that we need to take consideration is the data that we train. It's basically in the form of data frame. We need to convert that into a numpy. Right? So x train dot test is equal to x test dot to y test is equal to it's just I actually don't really need to do all of this. It's just so I don't make any errors. Yeah, let's fit them. X train. Okay, there's error. Okay, I know exactly what I'm doing. Yeah, we need to do the transpose of it. Since we are doing the dot operation, um, we need to do the transpose to basically find the value of this. Okay, linear dot predict x test. Yeah. So guys, we successfully predicted the model. So let's create a simple square array. Pretty much. Yeah, we are doing this together. Great. True value is greatest and predicted value is this is basically my prediction. So we get a decent model. It's yeah, it's fair because we only got about 15 minutes to build this from scratch, and we had to go through the mathematical part of it also. So it's basically fairly easy to build a linear regression model from scratch. And if you know how to build a linear regression from scratch, it is really easy to implement linear regression, bridge regression, and elastic net regression from scratch also. So keep in touch. We will be definitely making another video on building lasso regression, bridge regression, and other type of regression from scratch. So stay tuned.